I want to talk about a very important concept here when it comes to waves. I've got two different waves here. This one I had to paste together, so it's got some lines and breaks in it, but don't mind that. That's just because I pasted it together. And then I've got a period of time down here. Let's say that this period of time is 1 second. And I've got the same period of time here. Now here I have a high frequency wave, and here I have a low frequency wave. We've got, well, let's count them here. 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles, 6 cycles. I've got 6 cycles in this second. So this is 6 cycles per second. This is not even one. This is about a half of a cycle in that same second. Well, which one can I get more data into? Which one can I fit more data? Well, look, I can vary the amplitude or frequency or phase 6 times here in this first one, in this first second. But here, I don't even have a full wave yet. It's more difficult to change the amplitude, the frequency, or the phase as many times with a low frequency cycle. So I can get a lot more information. I can cram a ton of bits in this second, but I can't cram a ton of bits into this second. This is just simply more dense. It's a higher density of information at this top one. So higher frequencies, more data, faster data rate, if you will. In other words, I can move more bits per second with a high frequency than I can with a low frequency. But there is a downside, and that is that the high frequency has a shorter wavelength. From crest to crest here is very short compared to this one. This has this really huge crest, say from here all the way over to here. Well, it turns out that the more of these crests and troughs I have, the smaller this wavelength. And by the way, the 2.4 gigahertz wavelength or gigahertz frequency has a wavelength of about 2.5 inches or so, and it tends to peter out faster because it's absorbed by, more frequently and then retransmitted more frequently by materials as it passes through them. So as these waves pass through walls, the walls absorb more of that energy, and it turns out that I can't go as far with these high frequency waves. With these low frequency waves, it turns out that the absorption and retransmission is slower and happens less often, and these waves can travel through more walls and greater distance before they peter out. So here's the upshot. If you have, say, a 2.4 gigahertz transmitter, you can get less data in it, but it can travel farther. If you have a 5 gigahertz transmitter, you can get more data in it, but it does not travel as well or as far. So maybe the 2.4 will go all the way across your house through the walls without any trouble, but the 5 gigahertz may not. And you may not be able to get it in the bedroom if you have the transmitter out in the living room, say. So there's a plus and a minus to different frequencies.